In this video, we're going to talk about the differences between C++ and Java. Basically, it's just going to be an overview of the main differences. And in the notes, the link you should follow is this one, C++ versus Java. So the major differences between Java and C++ include memory management, project management, inheritance, some other language differences, and environment issues. So with memory management, the main difference is that Java does not allow the programmer to explicitly deallocate memory or to use pointers to reference memory. Java actually does use pointers to reference memories, but it's under the covers, so to speak, and you can't get access to those pointers, for example, by using pointer arithmetic. Java does allow you to explicitly allocate objects using the new operator, just like C++, but you don't use the delete operator as in C++. Instead, Java uses garbage collection to reclaim objects or memory that's no longer being used. Also, Java eliminates what are called stack allocated objects. You can no longer declare an object and have it be, such as a class object, and have it be allocated on the stack. Instead, you always have to allocate it off the heap using the new operator. With project management, Java introduces something called packages, which is a module mechanism that allows you to group several related classes together that are trying to accomplish the same purpose. For example, you might have a list class and a list node class, the list node class being a class that helps implement the list class by implementing the nodes of the list, and the list class being a container class that actually implements the functionality of the list. In C++, you could use friends and namespaces to try to imitate classes working together, but it's a lot kludgier. Java's package mechanism makes it a lot easier for related classes to share their implementation, such as access to instance variables. Secondly, as regards project management, Java does away with .h files. They decided that it was too complicated to separate the so-called interface from the implementation. So instead, they have everything associated with a class in one file, and the class name must match the file name. So here, for example, I have a class called Hello World, and you'll see down here that the name of the class or the name of the file is helloworld.java, .java being the suffix we use. Also, you'll see that the definition includes both the API, in this case hello world, the constructor, and the function main, as well as their respective implementations. And finally, Java does not require a makefile. The compiler is supposed to be able to compile a file, find all the classes that are mentioned in that file, and then use something called the class path environment variable, which will be discussed in another video, to find the directories containing these classes and compile them as well. On inheritance, Java tried to simplify C++'s inheritance mechanism by banning multiple inheritance. It also tries to separate what's called implementation inheritance from API, application programmer interface inheritance. So if you want to inherit a superclass's interface or its API, you use something called an interface in Java. It's a new type. Whereas if you want to inherit the implementation, then you would actually subclass a class. And again, we'll get into this later in another video. Secondly, Java differs from C++ in that all methods are virtual. In C++, by default, a method is non-virtual, and you have to explicitly declare it virtual. In Java, by contrast, all methods are by default virtual. you have to explicitly declare a method to be non-virtual if you don't want it to be. There are some other important language differences. The first is that Java is a completely class-based system, so functions cannot exist outside of objects. So even main is part of an object. If you go back and look at this class definition again, you'll see that I have main embedded within the class hello world. Also, Java's text-based I/O is a lot clunkier than C++, and the reason for that is that Java was originally designed as a graphical interface language. It was designed to have its input directed to a screen via graphical objects rather than to a console. After Java became popular, then the developers added ways to do formatted input and output, but it's clunkier. Again, in a couple later lectures, we'll talk about the scanner class that allows us to break up a line in Java into its composite fields. Fortunately, Java does have formatted output statements that are similar to C++, and in addition, they have some special formatting classes like the decimal format class that allows you to format certain things like money amounts, especially like money amounts when they're in the thousands are separated by commas in the US and by periods in Europe. And Java, being an internationalized language, provides classes that don't require you to hard code your formatting, but instead will determine the type of formatting appropriate to the region based on where the computer is located. So for example, if it was in Europe, the decimal format class would output periods as separators for money amounts in the thousands, whereas for the US it would be commas. Finally, there's some important environment differences between Java and C++. The biggest difference is that C++ compiles its programs down to machine level instructions, whereas Java compiles its programs into bytecodes and then interprets these bytecodes using a virtual machine. So a virtual machine is a software program that simulates a machine and its instruction set. And a virtual machine can be implemented on any platform. So Java is implemented on Linux, on Windows platforms, and Macs. And the programs are perfectly portable across these platforms because the bytecodes are the same for each platform. The virtual machine implementation is different, but you don't have to worry about that. As long as your bytecodes are the same, the behavior will be the same on any platform. And as a result, Java is called architecture neutral. Another difference between Java and C++ is that the Java virtual machine provides a great deal of runtime checking to ensure that the program does not breach the security of the platform on which the program is running. So, as an example, it does array bounds checking to assure that you never step beyond the ends of an array. And if you do, it will actually throw a runtime error and show you a message saying what the problem was. As another example, it will type check your downcast to make sure that it's being done in an appropriate way. If you have a class that is a stack and you try to downcast it to something nonsensical like a string, C++ will allow you to do it, whereas Java will throw an exception telling you this is an invalid cast. And finally, the virtual machine does garbage collection so that you can't get into problems with pointers. Pointers are a frequent way to exploit security holes in a machine, but by preventing you from getting explicit access to its pointers, Java closes the security loophole. So the bottom line is that providing this type checking, the virtual machine allows you to catch a lot of errors during your development much faster than with C++. So debugging times are shorter in Java. And if you do have some kind of problem that slips through to production, it's going to be easier to find that error. Also, the security problems associated with C++ are significantly diminished. On the other hand, this interpretation and runtime checking comes at the price of decreased efficiency. So even well-coded Java programs will run about 2 times slower than corresponding C++ programs. You may have heard about just-in-time compilers, which will dynamically try to compile bytecodes down to machine instructions, sometimes right before the program is run, sometimes as the program is running. However, they're still less efficient than corresponding C++ programs because it still performs runtime array bounds checking or downcast checking and garbage collection. And secondly, you can do better optimization when you have access to the original source code than just the bytecodes. Finally, Java does not create a single monolithic object file like C++ does. So C++ compiles all the files, object modules together into a single big object module. In contrast, Java compiles each class into a file of bytecodes, and then you provide the name of the class that contains main as the single input to the Java virtual machine. And then dynamically, as you allocate classes or reference other classes, the Java virtual machine loads these classes dynamically. And this is obviously slower because you're going to be dynamically loading classes, which could cause a pause as the class is loaded. On the other hand, Java was meant to be used over the internet originally, and that allowed the program to start up immediately executing, while in the background the virtual machine could be loading other classes that it thought you would need. So it would timeshare. It would be primarily executing your class, but it would be occasionally loading other classes over the internet as well. And this worked particularly well when Java was first introduced and bandwidths were particularly small at the time, as low as 128K. Your program could start executing, and hopefully by the time it got to requesting some class, that class had already been loaded. This is the end of this video, and in future videos we're going to be looking more closely at specific details of the parts of Java.